We've been working a lot on solving, and now we're going to go to graphing. How do we graph quadratics? So let's first of all, again, define what a quadratic is. A function that can be written in the form ax squared plus bx plus c. The key thing here is that our highest exponent is 2. So we have our parent function. For any new graph or function that you'll be introduced to in the next couple years, we will always have our parent function. It's the most basic version of the function. So here is our parent function. Our a value is 1. There's that 1 in front. And we're going to start by just graphing this and seeing what does this look like. We're going to do this by making an XY table. One of the first numbers I always like to plug in is 0. So I'm going to plug in x equals 0. If I plug in 0, 0 squared is 0. Then I'm going to plug in 1. 1 squared is 1. I'm going to plug in 2. 2 squared is 4. Let's plug in -1 and -2 as well. -1 squared is +1. Remember, when I plug that in, the negative gets squared to become a positive. -2 squared is 4. So let's graph this. I have a point at 0, 0, 1, 1, 1, -1, 2, 4, -2, 4. I did not do those very evenly. And here is our quadratic. Now that we know what a quadratic will end up looking like, now we have a bunch of vocabulary words to identify different parts of our graph. So go ahead and it's probably best if the video is paused and you can write all of these down, and then we'll fill pieces in after you've written it all down. Now that you've written them all down, let's go ahead and kind of go over them. So we have the parabola. That's what our graph is called. It's U-shaped. And a key thing about it is that it's symmetric. What it means to be symmetric is that I can fold somewhere and one piece matches the other. And so here I have this piece called the line or axis of symmetry. You might see it as LOS or AOS for short. And this is the line that divides the parabola into two matching halves. So if we go back up to the top where our graph is, our line is right here down the middle. That is our line of symmetry. So go ahead and draw that in. And we write it as an equation of a line. So x equals something. Up here, our line of symmetry, x equals, it's going through x equals 0. Our vertex is our highest or lowest point of the parabola, and we can have a minimum, which is the lowest point, or a maximum, which is the highest point. If we look at our parent function, our vertex is right here. It is 0, 0. Next, we have our x-intercepts. These are the points where the graph crosses the x-axis or touches the x-axis. And we write these as a number, comma, 0. So note here for our x-intercept, y will always be 0. Looking at the top, this is our x-intercept, 0, 0. It's where we touch the x-axis. Here we only have 1. Y-intercepts are the point where the graph crosses the y-axis. We write it as 0, comma, a number. So note here that our x is always 0. And in order to find it, we set x equal to 0. Again, if we look at our parent function, this is our y-intercept. This is not always going to happen. The vertex will not always be the x and y-intercept. This only happens for our parent function. Here are our last two key vocabulary words for graphing, domain and range. Our domain is all possible x values, and our range is all possible y values. I want to look back now at our parent function, and I want to write out what is our domain and what is our range. So domain is all x values. So we look at the x-axis, and I think to myself, is there any x value? So if I had an x value way over here, would I still be able to be somewhere on our curve? And I look, and my curve is going forever to infinity. So yes, over here, yes. I could also think, is there anything I can't plug into x? And the answer is no. I can plug any number into x. So we write this, which means all real numbers. Those are x values. Now for our range, range is the y values. And I ask myself, is there anywhere I don't have y values? And I look and I see I have no y values down here. My curve is only above the x-axis. So where's my lowest point? My lowest point is 0, and all y's are bigger than 0. So I write y greater than or equal to 0, and that is my range. Now I have some steps for you to write down before we go into graphing. Go ahead and pause the video and write these steps down, and then we'll talk through them. The first step is to find the vertex. So that's what we do first every time. Now, there's two different ways to find the vertex depending on which form we're in. The first way is if we're in standard form, and the other way is if we're in vertex, otherwise known as descriptive form. Remember, standard form is ax squared plus bx plus c. When we're in standard form, to find the x, we do negative b over 2a, and then we plug it in here and here to find y. If I'm in the descriptive form or the vertex form, my vertex is, notice this is a negative h, so we take the opposite of it and then the k. So we think opposite h, k. The next step is we have our vertex now. So I'm picturing on a graph, I have a vertex. I now want to find 2 points to the left or to the right. So I find 2 points to the left, and I can either make a table or I can use a pattern. And we're going to go over both of these in examples. So I find 2 to the left. My last step is I'm going to reflect those 2 points across the line of symmetry. So through the vertex, we have our line of symmetry, and we can reflect. So we just map them over. Let's go ahead and do example 1, which is in standard form. And I'm going to show you the different methods for how to find the other points. This is our standard form example. We're in our ax squared plus bx plus c term form. And our step 1 is to find the vertex. When we're in standard form, looking back at our steps, we find the x by doing negative b over 2a, and then we plug in x to find y. Let's find our a and our b. A is 1, b is negative 4. So our x is negative b, our b is negative, so I put it in parentheses, over 2a. This gives me 2. To find the y, I then plug it in. So I'm going to plug in 2 here, plug in 2 here. This gives me 4 minus 8 plus 1, which is negative 3. Let's go ahead and plot this. When I make my graph, I typically do a 5 by 5 on my paper. This here tells us that our vertex is 2, negative 3. Let's plot 2, negative 3. And then we're going to imagine our axis of symmetry going through our vertex. For step 2, I'm going to use the table. This is going to be our table example. You can use either methods on either form. So I could have used the pattern method, but I'll show that on the next example. We're going to make a little table. And for the table method, we're going to pick 2 x values to the left or right. I'm going to pick 2 to the left. Our x is at 2, so I'm going to pick 3 and 4. Plug them in to find our y. I get negative 2, positive 1. Let's go ahead and graph those. 3, negative 2. 4, 1. So it looks like we have half of our parabola here. And then step 3 is reflect. across the axis of symmetry or line of symmetry. This point is 1 to the right, so I'm going to have 1 to the left. This point is 2 to the right, so I'm going to have 1, 2 to the left. And here we have our parabola. The last thing I want to do is answer all of our questions for these. So we're going to find our vertex, our line of symmetry, y-intercepts, domain, and range. Our vertex is 2, -3. Our line of symmetry, if we go back to our notes, how do we write the line of symmetry? Let's look back. Line of symmetry, we write it as an equation of a line. X equals. Well, what x does it equal? It's going through x equals 2. You can note that it's the same as the vertex. Our y-intercept, if we look at our little graph here, it's at 0, 1. Write it as a coordinate. Our domain, we can have any x values, so it's all real numbers. For our range, that's all of our y values. I have nothing down here. So my smallest point is -3, and all of my y's are bigger. Y greater than or equal to -3. And those are all of your answers to those graphing questions. You will have to answer these on most of the ones you graphed today for homework. This is our last example. We're going to be in vertex form. Step 1, find the vertex. Looking back at our steps, we're in vertex form. So our vertex is opposite of what's here in our K. So this is -h. -3 is -h. So the opposite and then K. This means my h is 3, K is 1. Let's go ahead and draw our graph. Plot your vertex. Draw your line of symmetry through your vertex. Here I'm going to do the pattern method. Again, I could have used this method on either form. You don't have to use the pattern with the vertex form. Okay, so looking at our pattern, back in your notes, I'm going to write this all down again, and we need to find what our A is. So I look, my A is -2. We're going to go 1 left and right. 1 times -2 is -2. So we're going to go 2 down. 2 to the right. Then I have 4 times A. So 4 times -2 is -8. So we're going to go 8 down. And this is how we're going to count from the vertex. From the vertex, we're going to count 1 right and left. So I'm going to start to the right and then 2 down. 1 right, 2 down. So again, 1 right, 2 down. 1 left, 2 down. Then I'm going to go 2 to the right from the vertex and 8 down. 2 right, 1, 2, 3, 4, 5, 6. I need a couple more here. Let me count again. 1, 2 to the right, 8 down. 1, 2, 3, 4, 5, 7, 8. And then the same thing over here. 2 to the left, 8 down. 1, 2, 3, 4, 5, 6, 7, 8. And we have our parabola. And we can kind of skip step 3 when we do this one. So these numbers came from, this was 1A, this was 4A. And if these were positive, then we'd go up. Let's go ahead and do all of our vocab words. Vertex, line of symmetry, y-intercept, domain, and range. Well, our vertex is 3, 1. Our line of symmetry is x equals, it's going through x equals 3. Y-intercept, I can't tell what it is. So let's look back. How do we find the y-intercept? So let's look at our words. Y-intercept, set x equal to 0. So I'm going to make x equal to 0. Zero minus 3 is negative 3. Squared is 9. Negative 18 plus 1 is negative 17. And remember, we write this as an ordered pair. So it's 0, negative 17. Our domain is always all real numbers for any parabola we're doing. This time, though, we have a maximum. We have a top. What's the highest y value? The highest y value is 1. And then y is smaller. So y is smaller than 1 or equal to 1. And this concludes graphing. If you get home and you're confused when you're graphing them, please look back at the videos and rewatch them and try and follow the patterns.